Hello, welcome to another session of injection molding. Here we are going to look at different surface types and surface treatments. So we have an example of thermal cup. I have this design downloaded. So we'll first look at surface A and surface B. So what are surface A and B? Firstly, the surfaces which are exposed and users can directly see them are surface A. As in this case, all the red surface, the exposed part, is surface A, which the user can see. However, when we go in the section view, we see the surface B, which are the insides, which are not exposed and cannot be seen by user, are surface B. So the surface A should be neat and clean, have desired surface finishes, and surface B isn't really concerned. So surface B can have the injection ejection pin marks, gate marks, ribs, mounting bases, and other design features and surface imperfections, since they're not going to be seen by the users. However, as I said, the surface A needs to be looked neat and clean with desired surface finish. Now, there's one thing, the draft angle, that plays an important role in surface finish. As in last video, we talked that a minimum 0.5 degree draft angle is necessary in all the injection molding parts. However, if we need more surface finish, then the draft angle should be more than 0.5 degree. Another design standard says that for parts taller than 50 mm, increase the draft angle by 1 degree for every 25 mm. As in, if we're going 75 mm, then the draft angle should be at least 1.5 mm according to the standards. But there are exceptions as well. The draft angle also depend on the injection molding technology and machines we are using. Moreover, for parts with texture finish, increase the draft angle by 1 to 2 degree. Now let's have a look at what the texture finishes mean. Here we have all the standards surface finishes types, which start from A1 and ends to D3. So A1, A2, A3 are more shiny, and the B-type surfaces and C-type surfaces are more rough, and D-type surfaces are most rough. So uh, the surface finishes goes from more smooth to more rough from A to D. And it is very important to inform the manufacturer about the type of surface finish that we want, as in this case, any type of surface from A to D. There's another thing that we have to keep in mind, that the internal components, which of course have all the surface B, which are never going to be exposed to user, uh, can have a rough surface finish. As an example, I'm going to show you a part which is an internal component in a mechanism. You can see that this part seems to be 3D printed with a very rough surface, but you can see the ejection pin marks on it, which means this is injection molded, but still having a very rough surface finish because we really didn't want the good surface finish here. So that is all for the injection molding processes and surface finish types. See you in the next video. Thanks.